For this first exercise of the chapter, we're going to demonstrate how to work with virtual methods. We're going to do this by creating an employee class and then deriving a manager class from that employee class and overriding a virtual method in the employee class. So let's get started. First thing we need to do is create the employee class. We'll have two data members, name and salary. We'll have one constructor. And we'll say name equals N, salary equals S. All we're going to create for the rest of this class is the virtual method that we're going to override. So we're going to call this display info, and it will return the name, then a new line, and then the salary, and also a new line here as well. And that's all we need for this class. Next, we will derive a manager class from the employee class, so we need a colon with employee to indicate that manager is inheriting from employee. We'll add one new data member to the class, department, and then our constructor will have three parameters, the name, the salary, and the department. Then we call the base class constructor first with the name, N and S for name and salary, and we don't need a semicolon right there. What we need is opening curly brace, and then we set the department. And I see I made a little mistake right here. Let me fix that real quick. We only want D. I could use this with department, but I'm not going to. There we go. Now we're ready to override the display info method. So we're going to write public override string display info. You notice that when you do that, it automatically calls return base.displayInfo, which is fine, but I want to do it in my own way, so let's do it like this. We're going to say return base display info plus, and then we're going to write department plus a new line, like so, and then close the class. Got to have those open and close parentheses there. All right, so let's test our program. First, we'll create an employee object. Give it a name and a salary, and we'll call display info for that object. Then we'll create a manager object with a name, a salary, and a department. And then we'll call display info for that object. And let's run the program. And it works correctly. For the employee object, we get the name and the salary. And for the manager object, we get the name, the salary, and the department. So, to summarize, when we're creating a base class and we know a method is going to be overridden in a derived class, we have to mark that method virtual. Then in the derived class, when we want to change the definition of that method, we have to write override, because we're overriding the base class definition with this definition in the derived class. So that wraps up this first exercise on virtual methods, and we're going to move to the next exercise where we're going to look at another example of inheritance, and we'll be working with graphics in this exercise by creating a base class shape and an inherited class or derived class rectangle. In this exercise, I'm going to demonstrate how to create a graphics package by starting with a base class of shape and then adding another class rectangle. We start off by first creating the base class, which is shape. A shape will have nothing more than a simple XY coordinate, so we're going to have two variables, X and Y. The constructor will simply set values for the X and Y coordinates. X equals new X and Y equals new Y, like so. And then we do want to use properties this time, so we'll create a property X with set and get methods, and we'll do the same thing for Y. And then Y is equal to value. Finally, we're going to create a virtual method draw. Got to start with return. We need a semicolon there, close it off, close off the definition. My error there is because I created this as a void method. I was thinking I was going to use console write line, but I'll tell you what, I'm going to make it a string method, so that way we can return that. primarily because I don't like using console write line in my class definitions, but only at the user level. All right, so let's test this shape real quick. Shape S1 is equal to new shape, and we'll say it's at 1020. And then console write line S1.draw and console read key. We can run the program. Okay, so then we can take this shape class and create a rectangle class. So it inherits from shape. It will have its own set of methods, private int width and height, to define the rectangle. The constructor will set a new x, a new y, a new height, and a new width. So we'll call the base constructor with new x and new y, and we'll write height equals new height, width equals new width. And then we need some property methods for width and height, so public int height with a get return height, and a set height equal value, and then a property for width, return width. And then finally we're going to override the draw method, clear out the stuff it added to it. So we're going to say return drawing a rectangle at plus base x plus base y plus, and then we'll set the width and then the height. And that should be all we need. Close it out. Rectangle R1 equals new rectangle at, let's say, 3040 with a height of 10 and a width of 20. And then console write line R1 draw. So there we see that drawing a rectangle at 3040 with width of 20 and height of 10. So as you can see, from this shape class, we can actually build all sorts of objects, circles, and other types of geometric objects by using the shape class as a base and then deriving our other classes from that shape class. And this is actually how many graphics packages work. So now we've finished our chapter on inheritance, and now we're ready to move to the next topic in object-oriented programming, and that's polymorphism.